Hello Internet, in this video we are going to begin looking at how to create a shield shader in Unity. So this is going to be a multi-part series. I'm going to try to squeeze these down into smaller pieces and we'll see how that works. This is my first time trying that, so we'll see if that actually works or just goes horribly wrong. But anyway, in this specific video we are going to look at how to actually pass arrays to our shaders and how to use those. So what I'm hoping to do is sort of get like a heat map rendered onto this sphere. So what's going to happen is we are going to give it a object space point. So a point in object space, which means we can give it that and we can rotate it and it will kind of track with the object. So like if it's a spaceship and the shield goes around the spaceship, as the ship turns, the heat mark would track with the spaceship instead of kind of staying off in space. I think that'll appear a little bit more natural, but we can always change that later if we need to. So that's sort of all I want to get done in this video. And then in the next one, we'll look at like some refraction and some rim shading and things like that in order to make it look more sci-fi. So I already have a shield controller set up and a simple shield shader. There's nothing there. It's literally just a default surface shader and a default C# script. And a request to help improve ReSharper. We'll ignore that for now. So that's not strictly relevant to what we were doing, but this kind of is. And so we actually don't really need to do much here. All I need is the points on our shield that we want to render. So this, we'll just call this the points. I guess that works. And we don't really need to be too exact with this right now, because this is all about just kind of exploring this. Adding these new arrays to shaders is something new that Unity has added. It didn't used to be possible. You used to have to like pass it in a color array, or in a texture that was just like a one-dimensional color strip. That didn't really work very well, so this is kind of an improvement. We'll see how well it works though. So we're also going to want a reference to the material that we're actually going to be working with. So that we'll just call this the shield material. And then in our update, we're just going to set this up. So we pass to the shield material. We set an int. And so the first thing we need to do is actually set how many points there are in our array. It's not going to be hard-coded. This is closer to a C style array than say a Java or C# style array. It's not going to know how many things are there. You need to tell it. So that's what we're going to do here. We'll just call this like the points size. Sure, size works. And we can actually just pass in the points.length, and that should be everything we need. Then we just need to send in a vector array. Now this is going to actually pass in a 4D vector because that's just what they are. But we can actually just drop that final value in our shader and everything ought to work. I'm pretty sure. I've never actually done this before. So if it all explodes in my face, we'll know shortly. So we're going to pass in our points. We're going to actually just call this a vector4. That will make our types match and everything will be happy. And that, well, is that everything that I need to do? Let's see. I think that should be everything. Do I need to commit this or is it already committed? Some of these things you have to commit or to kind of signal to pass it over to the GPU. I don't think this is one of them, but I just want to make sure that I'm not missing something. I think we're good. So we need a point size and a points. And we also need a point color. So this is just going to be like a linear drop off from these points. We're trying to keep this simple, kind of have impact points so we can kind of visualize where things hit. And that's it. That's all we're trying to get done, is just visualize where things hit. So we're going to call this the point color. It's going to be an RGB value. We'll take a color. And the default we'll say is red. Does that work? I think I can do that. That may not work. Let me see if that compiles at all. I'm doubtful. Also, everything has been taking a long time to compile for me, and I'm not entirely sure why. That's a good example. No, okay. So I did all of that wrong. So let's just, if we're gonna do red's super easy. Let's just do red. And we'll give it a 1 for the alpha just because. We're never gonna use it, but it's there. And then let's actually bring down here. We are going to want our points and that set of points. So we can actually take in an int, and it's the point size. Is that what I called it? You can actually just copy and paste. And then we'll take the points. And this should be a fixed for array of these points. I've covered this in the past, but there's float, fixed, and half for precisions in your shaders. To my knowledge, most modern shaders treat them all the same, but I don't cite me on that because I'm not an expert on that. But they can be used interchangeably. They're all different ways to represent floating point numbers or fractional numbers. So a fixed, half, and float just represent different precisions of a fractional number. Right. So we have points, we have our point size. That should be good. Note that we don't actually need to expose either of these up here. These properties are just used to expose it to Unity. They're not used internally. All that is happening here is providing a nice thing for the material editor to actually be like, oh, there's a color defined inside of here that we need to use. That's all that's doing. So let's grab our point color, and then we should just be able to modify our albedo based on the proximity to that point color, which means we're going to need a world position. And we need the world position because we're going to turn it into an object position. Actually, thinking about this a little more, we may not need to do that. No, yeah, we will. Sorry. So I'm going to take the world position here, but we're actually going to be translating this into our object position. We'll change that later. It actually might be worth it to do that in like a vertex shader, because then we only do this once per vertex instead of once per fragment. But we can optimize that later if we need to. I'm actually going to leave it just as a world position for now. So this is not done. But the idea here is this way we can actually test. It won't change anything. It'll just change the space we're working in. So all of those points that we would specify would have to be defined in world space and not in object space. So let's see here. The next thing, we're writing out our color to the albedo. Do we want to do that as do we want to change the albedo, or do we want to change the emissive? I think it would be cooler if we changed this and say made this a fixed for of 0, 0, 0, and 1. So it's just not transparent, but it always is black. So it's not emissive initially, but then we're just going to write a simple for loop. So int I, where I is equal to 0, I is less than our point size, and then we'll just increment I. So standard for loop stuff. Normally control structures or like these kind of things aren't great in shaders. Usually you don't want like branching things, which a for loop or any kind of loop or if statements or anything like that. Those are all branching control things. And shaders typically, graphics cards in general, just don't really handle those as well. So that's sort of an obstacle, but it shouldn't be a problem here. We're not going to be destroying this in any amount of sense. So let's just add. Yeah, this will work. So what I want to do is add on the color. Do I even need that? Okay, this can actually not be a thing. Sorry. We can just make this a fixed thing and set it equal to 0. That's it. That's all we need to do. And then we want the max of 0 and then some calculation. And the reason we don't need that is because we're just having one emissive color. So I can do this dot emission equals the emissive times the point color, which will just multiply that color in at the end. So we don't actually need to keep modifying all 4 values. We can just do that later. Then let's do a distance check. So we want to check the distance from every point. So we're going to do points I. Let's see if I remember how to get the length or the distance between 2 points. I think it's just this. And then it would be the input.world position. I hope. And we're going to, if we do 1 minus the length, if it's exactly on, it will just be 1. But then this will scale it down until it hits 0 at 1 distance, when it would become invisible. So that will give us a one unit of range for this to actually kind of show up. I think that kind of makes a little bit of sense. It'll be a linear fall off too, so it should just linearly go away. Unexpected bracket. Don't say that. I don't want there to be an unexpected bracket. What? What? Well, this is awkward. The XYZ? Because we need to compare 2 3-point floating numbers. So the thing is we're getting an error that there's a bracket at line 35. Oh, it's saying this is wrong. Oh, ha. He. Ha. Got it. So that's not actually, that's all C# stuff. We're doing more of a C style thing. So let's kind of define it there. We may need to give it a size, but I'm not going to. Unexpected token square curly bracket at line 51. Oh, ha. Semicolon. Got it. Cool. Making all the mistakes. Unable to find an overloaded function of length. So we can't compare the length of 2 vectors? I guess it's not called that. This is going really well. Let's try distance. Sure. That's the next one we can try. I guess that worked. This is going well. I'm quite pleased that this is a massive disaster. But okay. No size for unsized array. So we do need to define a size, and it does give us an error. That's nice. So maximum points, let's give it 50. So we can have as many as 50 points in there, and then after 50, it kind of it gets a little bit much. But with that, let's actually create our shield and assign our material or our shader to that. Drop that on our sphere. I have no idea if that worked because there's no way for me to tell. Let's attach our shield material there. And then one other thing, let's make this execute in edit mode. This way we'll actually be able to play around with things in the editor without having to deal with all the other fun stuff. Well, I broke it. Hey. All right, cool. That was a massive success, I guess. Cool thing, we added that 1, which means it would be inserted at 0, 0, 0. Good news. Our example here, it's kind of small, but it actually worked. So if I move this here, you'll see it's actually glowing red. Remember, we made this an emissive channel, so it won't change the color. But if I move it here, you can actually see red there. And red, so effectively the red is just following the center of our map, which is exactly what we would expect with world coordinates, world space coordinates. So let's put that at 1 and 0 this. And so since this is 0'd now, when we convert this to object space, I expect to be able to rotate this sphere and for this color to stay in place. If that isn't happening, then it's not working. So that is the next thing we want to do. For that, we really just need to change this value. We need this input world space. I'm going to smack my mic a bunch, but we're going to change this input world space position to be in object space. And so there is a multiplication thing for that, which is something. Yes, it is definitely something. Let's do object position. Sure. And that's going to be a multiplication of world to object and the input world position. I think that's right. Unity has new functions for this, so it might actually, once it compiles, it might change this. Or it'll do that, whatever that was, that's now entirely white and our shadows are gone. Zero-sized array is not allowed, but we get rid of that. Ambiguous overload function reference. Welp. Unity world to object. Okay, so that's all it changed. Awesome. I think it wants it to be a 4-dimensional thing. Not entirely sure. That error is not totally clear, but also I think it wants this to be in 4 dimensions, so we can actually just add on a 0 at the end, and that should take the x, y, and z from our world position plus everything else. Can we just store this in a float 4? Let's try that. Let's see what happens. I'm curious now. This may just totally blow up in my face. Well, yep, okay. Float 4, it needs to convert to that. XYZ, cool. Cannot implicitly convert from float 3 to float 4. Okay. That's interesting. Huh. Oh, probably because that world position is expected to be a float 3. So back to float 4. Cool. Let's add the 0 at the end. I think we need another parenthesis. Nope. Did I get them all? I don't think I did. I feel like we're missing one. There we go. Cool. Got them. So that should cover that. And we're still getting those errors. Let me recompile this. The easiest way I know is just to save it again. We'll get some different errors. Ambiguous overload function. Huh. Well, that's interesting. I don't exactly know what is going on, why this is not working. Because we should be multiplying a... Oh, and Unity seems to be dropping my float 4. That's nice. I may need to go and look this up because this is definitely not going quickly. Yeah. Okay. I'm going to be right back. I'm going to go figure out what to do here. I think it's something simple that I'm missing, but we can figure that out. So, one moment, please. Okay. Permission to be confused. This works now. And I don't know why it works now and didn't work before. Because we tried this, right? I did this. I thought I could have sworn this is what I did. Right? I haven't gone back, but I'm pretty sure we did that, right? I did that, and it didn't work. Did I not save? Was that... Okay. Anyway, it works. And so what I had to do is actually make it so it was multiplying a 4x4 matrix, which is what this is, and multiplying that by a 4-dimensional vector, which is that guy. And then we can actually just take the X, Y, and Z components out of that. We don't need the W component. So I should just be able to do that. And it works, I swear. Okay, good. It's still working. And then I can actually rotate it, and you'll see that the red actually stays aligned with the rotation of the object and not just going right. So everything is actually doing what I said it would do, which is a nice change. That doesn't always happen. So that's pretty much how to get things into object space and kind of get this glow going. And so the next step, at least there's a number of ways we can do it. First, we can add like some rim lighting, so it kind of glows around the outside. I always think that looks really cool on these kind of shaders. We can also add like refraction, so it bends the light behind. We can do a grab pass to do that, which is also fairly straightforward actually. And then the next thing is I want these colors to actually fade out. And so the way we can do that is actually use this W component, this fourth component, to actually give them a position, but also a strength. And so different weapons or whatever can actually have different strengths, or we can use that to specify something else, like a totally different effect if we want. And so that can be used to kind of resemble that. And then we can kind of have some like splashes. It'll almost look like puddles or like ripples are hitting it. So you'll hit that and then it will move, maybe grow up to 1 or grow down to 0 or whatever. And that will send out like a shockwave across the thing. Maybe it'll bend the light. And that should be it. But we're going to leave it here for now because this is enough for now. And then we can build on this and go from there. So if you guys have any ideas on how we could change this, improve this, make this better, let me know in the comments and we will definitely see what we can do. If you guys want to just come and chat or hang out and talk game dev or just software development in general, there's a Discord channel in the description that you guys can come and join, and we can kind of, I don't know, hang out and do things. The pitch for that needs work. But anyway, that's that. If there's anything else you guys want to see, any other ideas you have, drop those in the comments. Can't really put them in the description. That wouldn't really work. but you can do it in the comments, and then I will definitely take a look at those, and we'll see if we can make some of those become a video, or 3 or 10 or however many it needs. So yeah, that's it for this video. So until next time, see you, internet. Slight alteration. We do actually have to. I didn't demonstrate this, but this the position, moving it, that didn't actually work. I should have probably tested that before I ended the video, but there's a really simple fix. We have to make that fourth component in our vector a 1, which is, oh, I'm gonna totally screw this up because I'm just totally speaking from like 2 years previous experience. Hegemony? Homogeneous. It's about making a vector homogeneous, which is going to actually allow it to be affected. So when it's 0, that means rotation will affect it, but positioning does not. Translations do not necessarily. By adding that 1, both of them should work. So there we go. Totally caught that before posting it to the world. Definitely a thing that fixes it and actually makes it do the thing that I said that it did. So that's it. Yep, it works now. Bye, I guess. Yep, bye.